Hey everyone, ready to get organized. Today we're taking a deep dive into dictionaries in Python.
Dictionaries.
Yeah, and you know what's cool? They're like the ultimate organizers, these key value pairs. I mean, they might not sound super exciting, but
They're way more powerful than they seem at first glance, that's for sure.
right. And the material you send over, it seems like a really solid breakdown of how dictionaries work. So I think this will be a fun deep dive.
Definitely, yeah. And you know what I always find fascinating about dictionaries?
What's that?
It's that, like you said, they seem so simple, right? Just these pairs of keys and values.
Yeah.
But they're actually the foundation for so many complex programs.
Really?
Yeah. They let you organize data in a way that makes it incredibly efficient to access, especially when you're dealing with, like, mountains of information.
So for someone who's maybe just starting out with Python, dictionaries are like a must-know.
Absolutely. They're a core part of the language.
Okay, sold. So let's start with the basics. What exactly is a dictionary in Python? Like, how would you explain it to someone who's never seen one before?
You know, it's funny. The best way to understand them is to think about, like, an actual dictionary.
Okay, a real-world dictionary. Got it.
Yeah, you've got a word you want to look up, right? That word is your key.
Key.
And the definition you find, well, that's the value.
I see. Key and value.
Exactly. In a dictionary in Python, it works the exact same way. It's a collection of these key value pairs.
So simple, yet so powerful.
Exactly.
And like that basketball player example they gave, right? Where Vardas was the key.
Yeah. They use Vardas for the player's name, Pavardos for the surname, and so on. Each one paired up with its corresponding value. So if you had Vardas, Romas, that would mean the player's name is Romas.
Well, that makes sense. So clear.
See? Simple.
And I noticed you can create these dictionaries in a couple of different ways, right?
That's right. You can use those curly braces, you know, the symbols, to just list out the pairs directly. Or you can use the dict function, which is kind of like setting up parameters and then assigning values.
Oh, interesting.
Both ways get the job done, though.
So is there like a preferred way or a time when one would be better than the other?
Honestly, for just getting started, don't worry about it too much. The key is understanding those pairs, keys and values. That's the foundation. Curly braces are usually the simplest way.
Yeah, that makes sense. Keep it simple.
Dick can be handy sometimes if your data is already structured in a certain way, but those are like finer points.
Okay, so we've got our keys and we've got our values. What are the rules for what can actually be a key or a value in Python?
Okay, so for keys, you actually have a good amount of flexibility, but there's one super important rule.
Okay, hit me with it.
Keys have to be immutable.
Immutable.
Meaning they can't be changed after they're created.
Okay, I'm with you so far. So like what kind of things would be considered immutable in Python?
Well, think about things like strings and numbers.
Strings and numbers. Okay.
Yeah, like let's say you were making a user database or something. Usernames would make great keys because they're strings, and they shouldn't really change, right? Or, think about levels in a game.
Levels in a game, okay.
You could use level numbers as keys because each level would be associated with a specific number, and those usually don't change either.
Got it. So basically anything that's fixed, that's your key. What about things that can't be keys then?
Good question. You can't use things that are mutable.
Mutable.
Yeah, like lists or even dictionaries themselves.
Dictionaries and dictionaries. Wait, we'll get to that, right?
Yeah, we'll get to that. But for now, just know those can't be keys. Python will actually give you an error if you try.
Okay, got it. So immutability for keys. And then what about values? Are there rules for values?
This is where dictionaries get really interesting. Values. They can be pretty much ANY data type.
Wait, really? ANY data type?
Yep. Strings, numbers, booleans, you name it. Lists, even other dictionaries.
Hold on. A dictionary can contain another dictionary.
Absolutely. It's like, nested folders, you know?
Oh, wow. I see. Like categories within categories.
Exactly. Remember that student example, the one with the Max Levis dictionary?
Yeah, I think I remember that one.
That one had the student's name, age, a list of their hobbies, and even another dictionary just for their grades. That's why dictionaries are so good at representing complicated information. They can hold pretty much anything.
Okay, my mind is a little blown right now. That's next level organization right there.
Yeah.
So we've built our dictionary, we've filled it with all this stuff. Now, how do we actually get to the information inside?
Oh, that's the easy part. It's super intuitive. You just use the key and put it inside those square brackets.
Square brackets, okay.
Yeah, it's kind of like you're indexing a list, you know?
Oh, I see.
So like if you wanted the basketball player's last name from that Žydas dictionary, you would just write Žydas Pavarde. Like that.
It's like you're asking the dictionary question, hey, what's the information for this key? Love it. And you can also ADD new key value pairs, right?
Yeah.
Or change existing ones.
Oh, yeah, for sure. You just use the assignment operator, the equals sign, like you're adding new games to that ménager de my dictionary, which I think means my games in...
Lithuania?
Yeah, that's it. So you do something like ménager de my new game, awesome description, and boom, you've added a new game.
Wow. So they're not just static things then. They can actually be modified and updated as you go.
Oh, yeah, they're dynamic.
Speaking of adding data, did you see that .update method?
Oh, yeah, .update. That one's handy.
It seemed like it was a shortcut for adding or changing, like a bunch of key value pairs all at once.
Right. Instead of doing each one individually, .update.
Yeah.
Lets you do multiple pairs. They use it to update that list of strategy games.
Yeah, and there was another technique I saw where they created a dictionary from two separate lists.
Oh, yeah. Merging the Dalikai and Pashimiai lists, right? Subjects and grades. Into that Manover-Tinamai dictionary. My grades.
Yeah, that one.
They use the zip function and a dictionary comprehension, which we can talk about later. But yeah, it's just showing how you can combine data in cool ways to make dictionaries.
Super cool. So we can create dictionaries, we can get the info we need out of them, but what if we want to work with all the data inside? Like if we don't know what keys are even there?
That's where iterating comes in.
Iterating.
Looping. Going through the dictionary and accessing all the keys and values, no matter how many are in there.
Okay, so that's where the for loop comes into play, right?
Right, exactly. But there are specific ways to use it with dictionaries. Like you can target whether you need the keys or the values or both. For example, if you use moxlevii.keys, that would give you all the student names from that moxlevii dictionary, which means students, by the way.
Well, Slavia means students.
Yep. So you're just getting the keys, the names in this case. And if you wanted just the values, like, say, the average grade for each student, you'd use moxlevii.values.
Oh, okay, I see the pattern. And if I needed both the keys and values?
moxlevii.items. That'll give you both nicely paired up. That's how they did that neat output of all the student info. And then there's the .get method, which is super useful.
The same one seemed important.
It's a safer way to retrieve values. Because if you try to access a key that's not in the dictionary, it won't crash your program. It'll just return none. Or you can set it to give you a default value. Really helpful for avoiding errors.
Nice. I like safety nets.
Will do.
So we can loop, we can access, we can check for specific keys. What if we need to remove data from a dictionary? Like a student graduates, they're out of there. How do we handle that?
Python gives us a few tools for that.
Ooh, removal tools. I like it.
Ah.
So what are our options?
We'll dive into those after a quick break. So you were asking about removing data from a dictionary. Let's say we've got that student who's graduated, and we need to take them out of our moxlevii dictionary.
Yeah, got to keep our data up to date. So what tools can we use to do that?
Well, first up, there's the .clear method. This one's kind of like a sledgehammer.
Sledgehammer?
Yeah, it just wipes out the entire dictionary. All the key value pairs, gone.
Oh, wow. Okay, so .clear is for when you just want to start fresh?
Exactly, like hitting the reset button. Now, if you need something more precise, there's del.
Del. Okay, tell me about that one.
Del lets you target a specific key value pair for removal. Like if you know the exact student you want to get rid of, you'd use del with that student's name as the key.
Okay, so it's like a surgical removal, precise and targeted.
Yeah, but there's a little catch with del. If you try to use it with a key that doesn't exist, Python throws a bit of a tantrum.
A tantrum? What do you mean?
It raises a key error, which can crash your program.
Oh, no. That sounds bad. Is there like a safer way to remove a specific pair?
There is. The .pop method .top is kind of like the best of both worlds.
Okay, how so?
Well, it removes the key value pair, just like del, but it also returns the value.
So you can still use the value if you need it. That's neat.
Exactly. And the best part is you can actually give .pop a default value to return if the key's not there.
Oh, that's clever. So it won't crash if the key's missing? It just gives you back that default value instead. No more tantrums.
No more tantrums, exactly. Now, what if you need to remove something, but you don't really care which key it is?
Ooh, interesting scenario. When would you do that?
Maybe you just need to make the dictionary smaller, but you're not picky about which pair goes. That's where .patem comes in.
.patem.
Yep. This one just removes an arbitrary key value pair, so it's not targeted. It just grabs one and removes it.
This is like a random removal.
Pretty much.
Right.
Useful when you don't need that level of control. So yeah, we've got options.
Wow, Python really gives you a lot of flexibility.
Right. It's all about having the right tool for the job.
Totally. So we've been talking a lot about individual dictionaries, but the material you sent mentioned lists of dictionaries. What's that all about?
Ah, yes. This is where things get even more interesting. We go from single dictionaries to collections of them, all organized within a list.
Collections of dictionaries? Whoa. Why would you need that?
Well, think about it like this. If a single dictionary is like a row in a spreadsheet,
Okay, one row.
a list of dictionaries is like the entire spreadsheet.
Oh, that makes sense. So each dictionary is like a separate record, and then the list holds all those records together.
Exactly. Like imagine you were building a library catalog system.
Okay, library catalog, I can see that.
Each book could be represented as a dictionary, right?
Yeah.
With keys for the title, author, ISBN, and all that good stuff.
Yeah, each book gets its own little dictionary.
Right. And then you could have a list of these dictionaries representing the entire catalog.
Wow, that's so organized. And those examples in the material, Precause, NIGOs, and Studentai, those were showing that, weren't they?
Exactly. Items, books, students, each one was a dictionary, all neatly contained within a list.
I love it.
Yeah.
Okay, so how do we actually navigate through these lists of dictionaries? It seems like it could get kind of messy.
It's actually really intuitive. It's just combining what we know about indexing lists with how we access data in dictionaries.
Okay, so two-step process.
Yeah. Let's say you want to get the price of the second item in that precause list.
Okay, second item, price. Got it.
You'd use precause one kaina. So one kind gets you to the second item in the list, which we know is a dictionary.
Right, because Python starts counting at 0.
Exactly. And then kaina fetches the value associated with the kaina key, which means price, inside that dictionary.
So it's like we're zooming in first to the right dictionary, then to the right key within that dictionary.
Precisely.
Awesome. And can we loop through these lists of dictionaries just like regular lists?
Absolutely. A simple for loop will take you through each dictionary in the list, and then inside that loop, you can work with the data within each dictionary however you need to.
So we could like calculate stuff or modify the dictionaries within the list, all while we're looping.
You got it. They had an example where they calculated the average grade for each student in that Studentai list, and then they even added that average as a new key value pair to each student's dictionary.
Wow, that's powerful. And I think they also found the student with the highest average, right?
Yeah, that's right. It's all about processing and analyzing that data.
My brain is doing backflips right now. It's amazing what you can do with these combinations. I feel like we've covered so much about dictionaries.